In this lecture, I'm going to cover some more of the tools available in Sculpt mode of the landscape system. I'm going to cover the first 7 tools in detail in this lecture, cover most of the remaining tools in the next lecture, and then the visibility tool will be covered in the landscape whole materials lecture. The first tool, Sculpt, we've already looked at a lot, but one thing we haven't looked at yet is its use clay brush property. When this property is set to true, it's meant to mimic sculpting the landscape as if it were made out of clay. So as you can see, this looks a bit different than sculpting with this property off, and can be used to produce more subtle landscape features. Okay, and then the erase tool, as we saw, can be used to gradually return terrain back to the landscape's base height. And then the smooth tool is used to smooth out jagged edges of the landscape. By using the filter kernel radius property, I can control how large of details I want smoothed out. Setting this value higher will cause the tool to smooth over a larger radius and thus smooth out larger details, while lower values will smooth over a smaller radius and only smooth out smaller details. For example, I have this jagged terrain here, and I'm going to smooth it out using the default value of 4, which results in this. And now I'm going to press Ctrl Z to undo the smoothing and get it back to what it was. Now I'm going to turn the value of filter kernel radius all the way up to 7, which will result in this. It will smooth away just about all of the detail. And now I'm going to undo the smoothing again, set it to its minimum value of 1, smooth again, and you can see that it's only smoothing out the small pointy tips of hills rather than entire hills at once. Okay, and then if this detail smooth property is set to true, it will use this value to determine the level of smoothing instead of the filter kernel radius property. And just like that property, higher values smooth out more detail, while lower values smooth out less detail. The main difference between the two properties is that detail smooth has a much finer level of control. Filter kernel radius can only be set to a whole number between 1 and 7, and thus only has 7 possible values. Detail smooth only goes from 0 to 1, but has 6 decimal places, so it can be set to a million different values. The other difference is that the default value does a lot less smoothing than the default value of filter kernel radius. So you can see that this is smoothing a lot less than when filter kernel radius was set to 4. Okay, and then there is this property, combined layers operation, which is also a property on the rest of the tools in this row. This property is relevant when using edit layers. This property specifies if the current tool's data should combine with all of the edit layers in the final result, or only the edit layer it is applied to. So to demonstrate, I'm going to select the Sculpt tool, then select Sculpt Layer 1 and sculpt a small hill into the terrain. Then I'm going to select Sculpt Layer 2 and sculpt another small hill. Okay, and now I'm going to select the Smooth tool and set the Combined Layers Operation property to false. And then with Sculpt Layer 2 still selected, I'm going to smooth over the hill I created in that edit layer. Then I'm going to try to smooth the hill I created in Sculpt Layer 1, but nothing will happen. That's because with Combine Layers operation set to false, I'm telling the engine to only combine the smoothing data I'm adding to Sculpt Layer 2 with other data from that edit layer and no others. And so if I set Combine Layers operation to true and then try to smooth the hill, it will work, because I'm telling the engine to combine the smoothing data with all edit layers. Okay, and note that this doesn't actually add the data to every edit layer, it just combines with the data of every layer in the final result. So edits made with this set to true are still non-destructive. So for example, if I toggle the visibility of Sculpt Layer 2 off, we can see that Layer 1 still retains all of its original height data. Alright, so next, the Flatten tool, as we saw, can be used to create flat areas of terrain. The way this tool works is, by default, whenever you click, whatever the height of the terrain is at the center of the brush at that moment will be stored in memory. And then, as you drag the brush around, the highlighted terrain will be either raised or lowered to match the height stored in memory. So, for example, I'm going to position the center of the brush at the midpoint of this slope here. And then I'm going to click and drag. And now, all of the area I dragged the brush over has been changed to that height. Instead of setting the height that way, however, you can enable this flatten target property instead. When this property is enabled, instead of setting the height by where the brush is first clicked, it will simply use the specified value here. You can either set the value manually, or you can use the eyedropper tool to select the height from the landscape. So for example, I'm going to set the height to the top of this hill here. And now, even if I first click on the bottom of the hill, the terrain will be adjusted to match the height that I specified, which is the top of the hill. Okay, and then the pick value per apply property sets how the target height should be set, assuming that the flatten target property is not enabled. With a default value of false, it will do what we've seen so far, which is to set the target height only when the brush is first clicked. But if pick value per apply is set to true, then the target height will also be updated constantly as the brush is dragged. So the result of this is that when used on uneven terrain, instead of adjusting everything to the same height and creating a perfectly horizontal terrain, the terrain will be roughly sloped. Alright, but even if I had a steady hand and could drag very smoothly, I probably wouldn't be able to create a perfectly smooth slope manually. So to do that, I can use the Use Slope Flatten property. When this property is set to true, it will flatten terrain at an angle. So by default, when pick value per apply is unchecked, the flatten tool creates perfectly horizontal terrain. But if you wanted to create a flat slope, you would set Use Slope Flatten to true. So for example, my terrain here gradually slopes upward, but it doesn't do so evenly. So with Use Slope Flatten set to true, if I click, say, here, and then drag, the terrain will have both its height and or angle adjusted so that the terrain is flat relative to an angle, based on the location I first clicked on. So if you want to carve a perfectly flat slope into the side of a cliff or hill, you could follow the workflow I just used, which is to set pick value per apply to true to carve a rough slope, uncheck that, and then check Use Slope Flatten to perfectly flatten out the slope. Alright, so next, the Flatten Mode property can be used to set the direction that the height of the terrain should be adjusted in. With it set to the default value of both, it will do what we've seen so far, which is to either raise or lower the height as needed. With this set to raise, however, the tool can only raise terrain, not lower it. So if an area of terrain is lower than the target height, it will be raised to match that height, but if it's higher than the target height, then it will remain unchanged. So for example, I'm going to click and drag over this area here, and you can see the terrain is only rising. It's not being lowered anywhere. Conversely, with this set to lower, the tool can only lower terrain. Alright, so we just saw how we can use the pick value per apply and Use Slope Flatten properties of the Flatten tool to create perfectly even slopes. But there is also a tool that is especially made for this purpose, and that is the Ramp tool. With this tool selected, left-clicking anywhere on the landscape will create one of the endpoints of the ramp. And then left-clicking again will create the other endpoint. And then you can click on either endpoint to select it, and once selected, you can move it using either the translation widget or by simply left-clicking again on a different area of the landscape. If you want to delete the endpoints for any reason, you will need to click the Reset button. Or if you have two endpoints placed and you're happy with their location, you can click the Add Ramp button to create a ramp between the 2 points. If there is any space under the ramp, the terrain will be raised to meet it. Conversely, if there is any terrain above the ramp, it will be lowered to meet it. Okay, and now I'm going to create 2 more endpoints. And I can adjust the width of the ramp using the Ramp Width property. Note that this changes not only the width of the flat part of the ramp, but also the total width, meaning all the way from its center to the part that touches the ground. So the area between the solid lines is the flat part of the slope, and the area from the solid lines to the dotted lines is the fall-off part. The fall-off part is the area where the sides of the ramp gradually slope down to the ground. So both the height of the ramp and the width of its fall-off area will determine how steep its sides are. I can use the side fall-off property to change the location of the solid lines only. So this defines how much of the width of the ramp is the flat part and how much is the fall-off. So if I set side fall-off to 0, there won't be any fall-off, and the sides of the ramp will be almost perfectly sheer, meaning completely vertical. Conversely, if I undo this with Ctrl Z and set side fall-off to the maximum value of 1, there will be no flat area, and the fall-off will go from the center all the way down to the ground. Alright, so next is the erosion tool. In geology, erosion refers to the process by which soil or rock is moved from one location to another by natural forces. The procession of erosion is generally slow and can occur over time spans of hundreds, thousands, or even millions of years. So in general, younger geological features will have less erosion, and older geological features will have more erosion. The erosion tool is used to simulate all the different types of erosion that cause soil to slide downhill. So I'm going to apply the tool to these smooth hills here. And now, instead of perfectly smooth hills, these hills now have some erosion and look much more natural. Okay, so when the erosion tool is used, the greater the difference in height between the different areas of the brush, the more erosion will be applied. And so the steeper a slope is, the more erosion will occur when I use the erosion tool. Because for any given brush size, the steeper a slope there is, the more of a difference in height there will be from one end of the brush to the other. But I can control how much of an effect the height difference has by using the threshold property. This property defines the minimum height difference necessary for erosion to occur. So for example, if I were to turn threshold up to its maximum value and then used a small brush size on the top of a tall, steep mountain, then not much erosion would occur because there's not much height difference and the threshold is so high. But if I made the brush size larger, so that it covers the mountain from top to bottom, there will be much more of an erosion effect because the differences in height now exceed the threshold. So lower threshold values will result in more erosion overall, but the effect will be more dramatic the more of a height difference there is across the surface of the brush. Okay, and then the iterations property is used to specify how many times to run the erosion simulation. So larger values will result in more erosion. But how is this any different than the tool strength property? Well, you can think of it like this. Let's say that the erosion is caused by a gust of wind. The tool strength property controls how strong that gust of wind is, while the iterations property controls how many times that gust of wind blew. Okay, so the erosion tool uses a noise pattern to apply its effects, just like the noise tool does. The erosion tool uses a noise pattern to apply slightly different amounts of erosion to different areas of the brush in order to produce a more natural look. And so the noise scale property works just like it does with the noise tool. It will change the scale of the pattern used to apply the erosion. And then the noise mode property works the same way as well, except that because erosion generally lowers the terrain, the default value is set to lower, and the raise in both values are rarely used. Alright, so next is the hydro erosion tool. This tool is used to simulate all erosion effects that are caused by water. This includes effects caused by both the initial rainfall and also the subsequent flow of that water down the hillside. So I'm going to apply this tool to these hills here. And you can see that it creates a much more subtle erosion effect than the regular erosion tool. It's easiest to see the change when applied to large distances in height. Okay, and like the regular erosion tool, this tool has several properties which control how much erosion occurs, with each affecting the end result in a different way. The iterations property controls how many times the simulation is run and is meant to represent the number of times it has rained in that location. The rain amount property controls how much it should rain during each rainfall, or in other words, the total volume of water that is rained each time. And then the tool strength property for this tool could be thought of as how much force the rainfall and flow of water applies. The sediment cap property controls how much sediment is in the water during the simulation. The friction caused by sediment causes erosion. So just like these other properties, higher values will result in more erosion. The initial rain distribution property is used to define whether the rain should fall in a random pattern or be applied to the entire area. When this property is set to both, the rain will fall in a random pattern as if it had rained in some places but not others. In this case, the rain disk scale property will control the scale of that pattern, just like the noise scale property controls the scale of the noise pattern for the erosion and noise tools. When this is set to positive, the rain will fall equally across the entire area of the brush. And then the detail smooth property works just like it does with the smooth tool. Larger values will erode more detail, while smaller values erode less detail. Alright, and that will do it for part 1 of the Landscape Sculpt Mode lecture.